Finally, we will summarize the piecewise linear method. Firstly, the piecewise linear method is divided into 3 steps to analyze the nonlinear resistor circuits. In the first step, we should get the piecewise linear model by using polylines to approximate the nonlinear curve. Then, for each line, we have to get their equivalent circuit and their conditions. Finally, by using the suppose verify method, we can find out which section it works and the Q point. The advantage of this approach is that if you know which line it works exactly, then for the line it is a linear system. So the methods such as the node method, the loop method, the Thevenin theorem, and the superposition theorem can be used without any taboo. But it also has shortcomings. First, it also has a problem of the accuracy. The problem we did just now is such an example. It is a straight line here, and here is also a straight line. As we mentioned just now, if the circuit is either working in this section or that section, that is no problem, because in these two sections it has a little error. But unfortunately, if it works in this section, then the precision will has a problem. Of course, we can also make this model more accurate. This is the first section, is the second section, this is the third, the fourth, the fifth, and the sixth one. We can make a lot of piecewise linear sections so that it will approximate such a curve under the condition of arbitrary precision. It can be realized, but it creates another problem. That is, as the number of the sections increase, or with the increase of the nonlinear resistor elements in the circuit, the number of the superposition you need to verify are increased greatly. What does that mean? Let's look at such a problem. Assuming that there are two nonlinear resistors in it, a diode and a common nonlinear resistor. The diode, we think it works in two sections. This is the ideal model of the diode, which will be discussed later. The resistor also works in two sections. We leave this question to you. For such a circuit, how many subcircuits do you need to analyze so as to solve the circuit? If you understand this problem, you will also understand the second deficiency of the piecewise linear method we mentioned earlier.